we continue our class for chapter 5 part 2, which is ideal transformer calculation. Okay, in reality the transformer is not ideal, but for your class only focus on ideal transformer calculation. So this is the important formula. N represent number of turns. Okay, NP means primary winding, number of turn of primary. NS means the number of turn of secondary winding. So same here, VP is the primary voltage. The primary voltage is at the left hand side. Secondary voltage at the load side. Okay, make sure that your primary side are usually the source and secondary is the load. Okay, and lastly the current I secondary is 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 the secondary current. IP is the primary current. Okay, if you can see here, NP and NS is at the same location, NP, VP, NS, VS. But for current, you have to flip it. VP, IS, VS, IP. So be careful when you write the formula. Okay, this one is at the same location, N and V at the same location, but I is flip. Okay, VP is here, VS is here, IP is here, IS is here. This is the transformer. Okay, transformer symbol. Okay, make sure you know how to draw it. And NP dot, this is to represent the number of turn, primary and secondary. Okay, how to calculate it is just easy. Okay, I give you an example here. 100 kVA, this is a apparent power S. Okay, usually the transformer are represented as S. And 132 kV, 32 kV. This is to write the voltage is usually primary, secondary. So this is a step down transformer. Okay, there are step down and step up transformer. So make sure you can differentiate it. Step up means that the voltage increase. Okay, step down means that the voltage decrease. This is voltage decrease from 132 to 33. This is step down voltage. Okay, ideal transformer, okay, has the rated load. Rated load means that this apparent power is fully utilized. Okay, with a 0.85 lag power factor. Means that the power factor is 0.85. Don't forget this is lagging. So you have to be careful lagging in leading. So the first question, if NP is 13200 turns, what is NS? So you can use this formula. And find IP and IS. This one is a little bit complicated because you have to refer to your chapter 2, which is the power calculation. So now look at the first question. If NP is 132, 13,200 turns, what is NS? So just use the formula, make sure NP, S and S. Okay, so rearrange it. NS equals to this. Insert the value 32,000. Okay, you get the number of turns, which is 330 turns. Now for the part B, find IP and IS. So how to calculate IS? You have to calculate IS first. So VS, you can see that 32. Okay, if you refer to the question, is 132 kV, 32 kV. Okay, assume that the source is at 0 degree as a reference. Because this is ideal transformer, the 32 degree is 0 degree also. There is no phase shift. Actual transformer has phase shift. But for ideal transformer, there is no phase shift. Okay, so the angle is same with the source, which is 0 degree. Okay, and the value given is in RMS. Okay, this is important. The value, if they give like this, it's usually already in RMS, even though the unit is not in RMS. Okay, all the value is given in RMS, except in the time domain, which has sin or cos, WT. So that one you have to convert to VRMS first, divide by square root 2, except that the unit is already RMS. So you have to be careful. But for this one is automatically RMS. So next, you look at the power factor, which is 0.85 lagging. So you need to find the angle. The angle is cos inverse power factor. You get the angle. Okay, because this is a lagging, the angle needs to be positive. If the lead power factor use power factor negative, just add negative here. In the calculation, negative, negative, negative for leading. But for lagging, just positive. Let it positive. After that, you calculate the complex power. Remember the formula, S equal to V S I S. Okay, IS equals to S divided by VS. And then don't forget conjugate. Okay, conjugate outside. After you get the answer here, you have to make sure that the answer is conjugate. So we continue. Okay, 100. Okay, this one is from S. So you can see here 100 kVA. This is apparent power, no angle. So you have to convert this to a complex power. Remember, this is the complex power formula. So take that value, the apparent power, and then take the angle. Okay, just put it here, divide by 33,000, which is VS. This one, just transfer here. And don't forget to conjugate the answer. So you just insert this into the calculator, you get 3.03, the angle of negative 31.79. So the conjugate will just, the original answer is positive. After conjugate, you just add negative. Okay. Then this is the IS. You get the IS. Now you get the IP. Just use this formula. Okay. BP over IS. VP over VS equals to IS over IP. Okay. Don't forget this is different. Okay. You arrange it. You get IP equals to this. Okay. For this case, okay, either you put an angle or not, the answer is still the same. Okay, but for current you have to put the angle. Okay, this one is negative. Don't forget negative. Okay, just transfer this. Okay, then you get the answer. So you can see that the primary current is much lower than secondary current because this is a step down transformer. Okay, so that's it. That is the end of chapter 5 part B. So we will continue chapter 5 part C in the next video. Thank you.